All right, before I start going over some of these problems to practice for the Unit 4 test, I want to mention that I'll go at a fairly brisk pace for this class, and I want to mention that there is a more patient presentation in other places in the YouTube videos. I'll just slide this in here for a second. For a very detailed explanation of rules for exponents, there's a video titled Exponents, Review of Rules for Basic Operations. For factoring, review of greatest common factor and factoring out the greatest common factor. There's also a video for factoring trinomials. And then if you want for some of the more complicated polynomials, any of the videos from 11.4, let me move this up a little, any of those videos from 11.4, almost all of them show both methods using the box and factor by grouping. Okay, the other thing I want to mention is that I will be referring to these rules for factoring, so if you're not familiar with these or if you don't have these handy, you might want to pause the film for a moment, go out a little bit, and have these written down because I'm not going to be able to keep pushing this in front of the screen, but I'll refer to number 1, number 2, number 3, number 4, etc. Okay, let's go ahead and get started solving some of these. Let me zoom in a little bit, and we'll take a look at number 2. They want us to, well, let's back up to the directions here, find the value of the expression for the given replacement value. So they're asking us to plug in this -4 wherever you see an x. Okay, so we'll have to plug it in here, 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 and here. To be real safe, when you're working with a negative value, I strongly suggest you put parentheses wherever the variables are and then plug in your values. Okay, so I'll do that. That'll be my first step. Wherever I have an x, I'm just going to put a set of parentheses. And then for the bottom, and remember, they're telling us that x is -4. Well, let me bring down all the other items that I haven't filled in. This parentheses will have to be squared. This minus sign, we've got a 10 in front. Should have left a little more room for that. Plus 5, and then that'll be squared. We have plus 2x. So plus 2, the x is again in those parentheses, and we have -1. Alright, so I hope it's clear what I've done there on the first step. Strongly encourage you to do that whenever you're plugging in a negative value. It has a very specific meaning, and parentheses is really the only way to contain that meaning. Alright, so x is a -4. That means I'll put -4 wherever there was an x. Okay, and now there's no more variables to worry about. You simply simplify the expression, and you'll always follow the order of operations. It's always in play. There's just no other concerns right now. So let's see. You have 2 sets of parentheses over here. So maybe I'll solve that off to the side. Okay. The 2 is touching the parentheses, so that's what you have 2 sets of. And we happen to know there's a -4 in each set. When you multiply those, you'll get 16. So right where that -4, the quantity squared, was sitting, I'm going to put a 16. Obviously, the exact same thing is going to happen on the bottom, so I'll put a 16 down there as well. Okay. Let's get our fraction bar in here. And let's see. This is a -10 times a -4. That'll give us a +40. Okay. And then on the bottom, positive 2 times a negative 4 gives us a negative 8. And then we'll just bring down whatever we haven't touched, which is our positive 5 and negative 1. Okay? And now, cleaning up what we have up top, 16 and 40, that's 56, plus 5, 61. And then on the bottom, the difference here would give us 8, and subtract 1 more gives us 7. Oop, I'm sorry, I've run off the paper here. Let me zoom out a little. Slide this up. There we go. Alright, so when we combined these terms, we got a 61. When we combined these terms, we got a 7. Okay? So that's our final answer for that. And 7 won't go in there evenly, so I'm just going to leave that as an improper fraction. Okay, so that takes care of number 2. We'll see number 3 here. Let me zoom in a little bit. Okay. The formula for the focal point of a lens. In this formula, basically you're just going to be plugging in values. They've given you A is 12 centimeters, B is 6 centimeters. Once we do our calculation, we're going to perhaps have to do a little division, and they're going to want us to round to the nearest tenth of a centimeter, okay, if that situation should arise. So for A is 12. Oh, and by the way, notice calculate F. That F is equal to. So once you plug in these values, you're not going to have to solve anything. You're just going to have to clean up this side of the equation, okay? If they had given us F and A, we would have to solve for B, etc. But we'll just be able to plug these in right now. So A is a 12. All right. So right where the A is, we'll plug in our 12. And let's see, down on the bottom we have a 12 as well. Let's get our fraction bar. Up here it's going to be multiplication. On the bottom it's addition or subtraction. And what the heck, let's just say F is equal to. Alright, then for B, they tell us B is 6 centimeters. So right where the B was sitting, we put in a 6. Okay, and on the bottom we had a B sitting there, we put in a 6. And now we're just going to clean this up a little. Let me zoom out. So when we multiply 12 times 6, I think I'll go sideways in this case. Well, alright, so 12 times 6 would be 72. And 6 plus 12 is simply 18. So this reads 72 divided by 18. So we'll go ahead and solve that. Well, you could cut them in half pretty fast to make your life easier. In fact, this cleans up real nicely. Instead of going through all the trouble of the division, let's just simply reduce this, at least to start. Just give us smaller numbers that way. So 18 divided by 9 and 72 divided by 9. All right, let's see where that gets us. 72 divided by 9 is going to be an 8. 18 divided by 9 is going to be a 2. Looks like this is working pretty nicely. And 8 divided by 2 is simply a 4. So F is equal to 4 centimeters. Okay. If we had gone down the long road, it would have given us a 4, but this was just an easier way to proceed. So that takes care of number 3. We'll also deal with number 4 here. And perhaps zoom in a little. Okay, find any numbers for which the rational expression is undefined. Remember, I am not concerned, well, this is something we've talked about a fair bit. Just a quick review here, okay? This is just off to the side. If you have 0 over 5, the answer to that is 0. But if you have 5 over 0, that is undefined. All right? You can't have 0 in the denominator because division by 0 is not defined. And, well, I've talked about the reasoning before. Basically, at this point, if you're not clear, just memorize that. And for solving this, that means we're not concerned about the numerator. With the denominator, you don't want this whole thing to turn into a 0. So if the value of x was a 1, you would have a negative value down here. You wouldn't care. If it was a 2, it'd still be a negative value. If it was a 10, you'd have a positive value. There's one value that we can't let x become. X cannot be 9, because if x is 9, you'll have 3 times 9 is 27. If you subtract 27, that'll give you a 0 in the denominator, and this entire expression would be undefined. So sometimes you can just look at it and figure that out. If you're not able to do that, just take the denominator and set it equal to 0. You're basically looking for trouble, so to speak. You want to find out when the denominator causes trouble. So for this, you would solve for x, add 27 to each side, and that's going to leave you with 3x equals 27, and you're going to get rid of your 3, so divide by 3, and you'll be left with x equals 9. So it looks kind of funny this way. Find any numbers for which the rational expression is undefined. It's undefined for x equals 9. Okay? I'm a little uncomfortable writing it that way because the one thing x cannot be equal to is 9. But if you're directly answering this question, that's how you would answer it. Okay, that takes care of number 4. We'll also look at number 6. And that's a little bit of a trick. It's the same question, any value for which this rational expression is undefined. There's no variable in the denominator. So again, it's a little bit of a trick because there is no value. R can be anything in the world, but it won't cause a 0 to show up in the denominator. Okay, so that's kind of a trick. Taking a look at, well, I think we'll stop right there.